Welcome to the lesson on de-energizing high-voltage systems in battery electric vehicles. In this lesson, we will explore the steps involved in effectively de-energizing high-voltage systems using the manual disconnect method. In this lesson, you will be able to explain the importance of de-energizing high-voltage systems in battery electric vehicles and recognize the crucial role of de-energization in ensuring safety during service and repair. Secondly, you will be able to identify situations requiring high-voltage system de-energization. Thirdly, you will be able to list the key components to de-energize. Next, you will be able to list and name the essential prerequisites and tools before de-energizing the high-voltage systems. Then, you will be able to describe the main methods for de-energizing high-voltage systems. Finally, you will be able to list the steps involved in safely de-energizing high-voltage systems. High-voltage systems are essential components of battery electric vehicles, powering everything from the electric motor to the onboard electronics. However, high-voltage systems also pose inherent risks, including the potential for electrical shocks or hazards. De-energizing high-voltage systems is a critical safety procedure that involves de-energizing or isolating the high-voltage components to ensure the safety of technicians working on the vehicle. This process is typically performed during maintenance, repair, or emergencies to prevent electrical shocks or hazards. Following proper procedures and protocols ensures that work can be performed safely and effectively while minimizing potential accidents or injuries. Only specially trained technicians with the necessary knowledge, skills, and equipment should attempt any work on high-voltage systems. Technicians must be certified to handle high-voltage systems according to industry standards and manufacturer guidelines. In this lesson, we will examine why technicians need to de-energize high-voltage systems during service or repair. Next, we will look at when de-energizing is needed. We will focus on the components that require de-energization. Then we will look at the requirements before high-voltage systems are de-energized, such as personal protective equipment and appropriate tools. Following that, we will look at the methods to de-energize, namely the manual and the scan tool methods. Finally, we will look at the guidance procedures, including the manual disconnect method's various steps to de-energize high-voltage systems. Why should technicians de-energize the high-voltage systems? The most critical reason for de-energizing high-voltage systems is to protect a technician from a potentially fatal electric shock. Battery electric vehicle high-voltage systems operate at hundreds of volts, which can easily overwhelm the human body's electrical limits and cause cardiac arrest, severe burns, and even death. De-energizing the high-voltage system effectively cuts off the power supply, making the work environment safe. Even a seemingly minor touch of a live high-voltage component can send a jolt through the system, potentially damaging sensitive electronic components and causing malfunctions. Accidental energization during repairs can also lead to uncontrolled electric arcs and fires, posing a significant safety hazard. De-energizing the high-voltage system eliminates the risk of accidental activation, protecting both the technician and the vehicle's electrical components from harm. With the high-voltage system de-energized, technicians can confidently access and work on components, knowing they are not dealing with a live electrical circuit. This allows for safe and accurate parts diagnosis, repair, and replacement. De-energizing high-voltage systems is not just a recommended practice. It is necessary to ensure the technician's safety, prevent equipment damage, and enable efficient repairs. It is the foundation for any responsible maintenance or service procedure. When should technicians de-energize the high-voltage system? De-energizing the high-voltage system is necessary only when technicians perform service, repairs, or testing on circuits with orange high-voltage cables/conduits. Always consult the manufacturer's service information. Different models might have specific procedures or components requiring de-energizing even during routine tasks. Remember, orange high-voltage cables are the key identifier. Any circuit connected by these cables needs a high-voltage system de-energized for safe intervention. Remember, de-energization is not necessary for all types of maintenance. Routine maintenance that does not require de-energization includes visual inspections, replacing certain components, and software updates. Visual inspections include checking tire pressure, fluid levels, and the vehicle's exterior condition that do not require touching the electrical components and can be done safely without de-energizing the system. Some components, like cabin filters, tires, or brakes, can be replaced without accessing the high-voltage system. Many battery electric vehicles receive software updates over the air, eliminating the need for physical involvement in de-energization. The best way to determine whether a specific maintenance task requires de-energizing the system is to consult the manufacturer's manual for your vehicle model, as it will provide you with specific instructions and safety precautions for different maintenance procedures. Situations that require de-energization include any work involving the high-voltage battery, inverter, charging port, or other high-voltage components requiring de-energizing the system to prevent electric shock and other hazards. Diagnostic procedures that involve using insulated hand tools require de-energization for safety. Any repairs or maintenance involving electrical components connected to the high-voltage system requires de-energization. The best way to determine whether a specific maintenance task requires de-energizing the system is to consult the manufacturer's manual for your battery electric vehicle model, as it will provide you with specific instructions and safety precautions for different maintenance procedures. What components require de-energization? Physically testing or repairing components and circuits such as the electric motor, the AC compressor, the high-voltage battery pack, and the inverter and converter requires de-energization. Always consult the manufacturer's service information for precise instructions. Let us now look at the requirements to ensure you are safe. When working on high-voltage systems, wearing appropriate personal protective equipment that includes gloves rated for 1000 volts DC, safety glasses and face shield, flame-resistant and arc-rated clothing, and electrical hazard safety footwear are crucial to ensure the safety of technicians. Safety glasses provide eye protection against potential hazards such as electrical sparks, debris, or chemical splashes. Additionally, a face shield offers an extra layer of protection by covering the entire face, including the eyes, nose, and mouth, from any potential impact or splashes. It is essential to have a BEV-trained assistant present throughout the entire process. This technician should be familiar with the specific vehicle model, understand high-voltage system protocols, and be able to provide immediate assistance if any unexpected situations arise. The presence of a battery electric vehicle-trained assistant adds an extra layer of safety and ensures prompt action in case of emergencies. These safety measures help mitigate the risks associated with working on high-voltage systems and minimize the potential for injuries. Before using the manual disconnect method, it is crucial to understand CAT ratings. CAT 1 is the lowest CAT rating intended for use in circuits not directly connected to the mains. It is typically used for low voltage and low energy circuits, such as electronic and battery-operated devices. It provides limited protection and is suitable for basic electronic testing. CAT 2 rated equipment is designed for local-level electrical systems, such as household and portable appliances. It can be used to test electrical systems in residential and commercial buildings. CAT 3 rated equipment is intended for fixed installations, such as distribution panels and industrial systems. It is also suitable for handling most current battery electric vehicle high-voltage systems. CAT 4 is intended for use at the source of the installation, such as at power substations and overhead power lines. Remember, CAT ratings are intended for general guidance, and specific safety protocols may vary depending on the application and manufacturer's recommendations. Always consult the user manual and prioritize safety when working with high-voltage systems. Having and using appropriate testing tools is crucial before performing the manual disconnect method. CAT 3 rated digital multimeters, DMM, are designed to safely measure voltages up to a certain level in electrical systems, typically above 500 volt DC. However, they are not equipped to output high voltages for resistance testing of high-voltage components. This limitation means that while they can accurately measure voltages within their specified range, they cannot generate high voltages necessary for certain types of diagnostic testing on high-voltage components in battery electric vehicles. Therefore, when performing resistance testing on high-voltage components, technicians may need specialized equipment beyond the capabilities of a CAT 3 rated digital multimeter. High-voltage insulation testers are specifically designed to measure high-voltage equipment's insulation resistance, typically ranging from 1 kV to 10 kV or higher. MEGO meters and insulation testers offer high test voltages for measuring insulation resistance but may have different functionalities and features. The appropriate tool for high-voltage resistance testing depends on the specific application, voltage requirements, and desired test parameters. A high-voltage digital multimeter is versatile for high-voltage measurements like voltage, current, and resistance. A dedicated megometer is the right tool for testing the insulation resistance of high-voltage components due to its high-voltage output and specialized features. Always consult the manufacturer's recommendations for the components you are testing to determine the required test voltage and choose the appropriate instrument. The manual disconnect procedure involves physically isolating the high-voltage battery from the vehicle's electrical system using manual steps and verification techniques. One essential tool used in this method is the digital multimeter. A digital multimeter is a versatile electronic instrument that measures various electrical parameters such as voltage, current, and resistance. The procedure typically begins with disconnecting the 12-volt battery. Then, technicians locate the manual service disconnect, which is a physical switch or mechanism designed to disconnect the high-voltage battery from the rest of the vehicle's electrical system. The DMM needs to be tested for proper functioning. After locating the manual service disconnect, technicians use the digital multimeter to verify electrical isolation by measuring the voltage across specific points in the high-voltage circuit. This verification step ensures that the high-voltage system is de-energized and safe to work on. Once electrical isolation is confirmed, technicians can proceed with their maintenance or repair tasks on the high-voltage system. The scan tool method provides an alternative approach to perform the high-voltage de-energization, often relying on diagnostic scan tools available in modern vehicle service environments. Unlike the manual disconnect procedure, the scan tool method may not require the use of a digital multimeter. Instead, technicians use specialized diagnostic scan tools to communicate with the vehicle's onboard electronic control units and execute the high-voltage disconnect remotely. With the scan tool method, technicians can command the vehicle's high-voltage system to enter a safe state or disconnect mode directly from the diagnostic tool interface. Although the scan tool method offers convenience and efficiency, its availability may vary depending on the service facility's vehicle make, model, and diagnostic capabilities. If the scan tool method fails, go back to the manual disconnect method. Regardless of the method chosen, both procedures necessitate the disconnection of the high-voltage battery and the manual service disconnect. The manual service disconnect serves as a physical safety mechanism to ensure complete electrical isolation of the high-voltage system during maintenance or repair activities. By following either the manual disconnect procedure or the scan tool method, technicians can work safely, minimizing the risk of electrical accidents and ensuring compliance with safety protocols. Regardless of the chosen method, always follow the manufacturer's instructions meticulously, as each model might have specific procedures or variations in the disconnect methods. For this lesson, we will primarily focus on the manual disconnect method.